we have a stacked agenda. So it's going to be pretty good. And so first of all, we're going to be going through what alpha is with the co-founder, Zac. Then we're going to be going through what you can build with the co-founder, Joe. And we've got David as well to be doing the interview. And then finally, we're going to be going through how you can get started building with myself and also Rob. So get excited. I feel like I've said excited like 10 times now. Grab yourself a snack, a drink, and let's just settle in and get started. So like I said, first of all, we've got Zac, who's going to be going through what alpha is. So Zac, I hear you've got a very special announcement.
Hello.
Please introduce yourself.
Yeah, happy to. Is this the camera?
This is the camera
That's
for
the
you.
camera.
Yeah,
Okay,
yeah.
Hello. Brilliant.
And then we've got a wide angle, I think.
All right, GM everybody, thank you so much for tuning in. Thank you for the introduction, Ciara. This is also, a bit new for me. Is it new for me? I'm just, whatever. I'm sleep tired.
In a studio like this, maybe.
I'm in a studio, yes. The production values are much better than we're normally used to. So Aztec, Alpha, yes, we have an announcement to make, which is that Alpha is live.
Woo!
So what do we mean by alpha, right? So,
in the simplest terms, can you explain to me, just like in a nutshell, what is alpha?
Yeah, it's real. That's what it is. It's so the proper network that fully functions as decentralized sequences, provers, transactions, etc. is all now deployed. Our rollups are on Ethereum mainnet. You can send transactions to them. You can send transactions to the Aztec network that interact with Ethereum. And so it is effectively a mainnet, but we are calling it alpha because it still has we are. Joe will go into this in more detail, I imagine. There's still a few things that we're going to have to iron out, a few security issues we need to validate. But the core functionality is now there, and people can build and they can deploy and they can use it the way we always intended after so many years.
Yeah, which is so exciting. It's like early Ethereum, right? Like we're right at the start. Everything is exciting. Everything's iterating and going so fast. So it's just a really exciting time to get involved, I guess, for developers and for users.
Yeah,
alpha
absolutely.
is feature complete. So can you tell us a little bit about what that means and also about what the journey from just wanting to bring assets on chain, which is, I think, where you started, right?
Yep,
and then how we got to here and just like a little bit about that.
Yeah, so sorry, the first question again?
Just about it being feature complete, what does that mean?
What does that mean? Well, it means that, so you now have the full execution environment of Aztec, so you can write a smart contract using our programming language Noir, which has, like an Ethereum smart contract, it has storage, it has functions, and your functions can call smart contracts and other functions, and you can emit events, and you can connect all of it to all of this with an application, and you can use Aztec as a distributed ledger, but it's private. So you have hidden information, encrypted information that your smart contracts can analyze. Things like private notes, encrypted balances, hidden user identities. So even for like a basic token example for Aztec, if I send a token transfer on Aztec, you don't know. If you're an observer looking at the network traffic, you don't know who I am. You don't know what smart contract I'm interacting with, and you don't know what data I've modified or changed. Yes, I performed a token transfer because I have but the transaction contains a zero knowledge proof that validates the correctness of the logic of the smart contracts that I have called. And obviously, this is all extracted away from the user and the developer. You write a smart contract; it has storage, and you have functions, and then you just call the functions on your client. And everything just works, and it all feels and looks very automatic.
I want to be just really aware of the fact that some of the people tuning in might not actually know really what Aztec is. So if we just zoom out for a second, are you able to just in maybe like one or two sentences, maybe two, say what actually is Aztec and why you think it's really useful? Yeah,
so it's a private distributed ledger. I don't know how far back we want to go. Like, are we talking blockchain native people or?
We can talk about, let's say Ethereum
I'll take
ecosystem.
Ethereum. Take an Ethereum smart contract, but make it so that information in that smart contract can be encrypted and hidden, so that you don't know, you don't know whether a transaction is modifying that information. However, the smart contract itself can still process logic on that information. So you can do things like have a token, but you can hide the balance from the world, or you can hide user identities from the world. And so what this enables really is it allows for blockchains to accumulate and accept sensitive data about ourselves, institutions, companies, events happening in the real world. Allows you to put that data in smart contracts in encrypted form and have distributed smart contracts programs operate on that information. And this explodes the universe of what you can build with a blockchain. For example, if you want to do anything kind of like real world asset stuff, the smart contract needs to understand who you are as a user, because they need to understand whether you can hold that asset, right? Because you have to all these weird conditions that have to be satisfied in the real world. And right now, a smart contract on Ethereum can't do that, but it can in Aztec. You can just do basic things like hide. Like if you're a whale and you're trading and you don't want people to see your positions, well, yeah, you can do that on Aztec. You can even now use Aztec to hide your identity on other networks, other L1s, other L2s, by using Aztec as a proxy, so that effectively the Aztec network is acting on your behalf and people don't see your true identity.
Being able to have privacy in the Ethereum ecosystem by having Aztec. We are obviously at this alpha stage, which you were describing a second ago. Let's just go into a little bit more about alpha. Yeah. So this was passed by governance, right? Do we want to talk a little bit about what that means that it was passed by governance and why this was so important to us about like decentralization, and why that is the sort of cornerstone of Aztec, as we really care about decentralization.
Totally. So most networks that launch these days are centralized in some way, right? You either have a single entity that's accepting and processing transactions, or you have an entity that can like pause the network or block the network or censor people. And we've always felt this is really just not this kills adoption, because if you're building a product or a service and you're deploying to a blockchain network, you need to have very strong confidence that this network is completely neutral, it's reliable, it's not going to rug pull you or change its parameters to affect you or undermine you. And so you, like Ethereum, you need decentralized governance. And so before our alpha upgrade, we did have a version of Aztec on Ethereum that was processing blocks, but the gas limit was 0. Basically, there were no transactions. And so we submitted a governance proposal saying, hey, listen, we want to increase this gas limit now because the network is functional. And our sequencers voted on it, whether to accept it or to refuse it. So they could have refused. And like this who submits proposals, who votes on them. This is not something we control. Anybody could submit a proposal. Somebody could submit a proposal saying, hey, let's just shut this all down, or actually let's just like ignore Aztec and bridge everything to another network. Hopefully I'm not stealing any ideas to anybody, but basically we don't control this network. And I mean that in reality, as in not some theater where like we say, oh, we don't control it, it's token voting, but we hold all the tokens. It's like, no, the foundation's not using its treasury to vote for any of these things. It's purely run by our sequences. It's proper decentralization.
Which is really cool, because without decentralization, you can't really have privacy, can you? Like, if there's a point of failure, right? Like there's let's say the sequencers were able to see the private data. If there's one sequencer who's yesing and knowing everything, then that's not really privacy, is it? Because we're revealing it to that one centralized sequencer.
Exactly, yeah. Like to give it an analog of the internet, imagine if all the internet traffic went through one company, let's call it Megacorp. Megacorp processes all the internet traffic. Well, then some men in black suits would turn out to Megacorp and go, hello, we want to see everything that's happening, please and thank you, and like you're now liable for everything that's happening. It's not a network at that point. It's a product of a company, and so for Aztec to survive, to thrive, it needs to be not just some expression of some corporate entity. It needs to be a proper distributed network, like the internet, like HTTPS and IPv6 and all of that. And so that's what we've built.
Yeah, I mean, it's so cool that after, so much hard work from the whole team and yourself, that we've finally got to this place where we have alpha. And as I was saying earlier, one of the key things that I know that you were so passionate about is making sure that it was feature complete from day one. We have everything now. We're not saying I pinky promise later we're going to have private state or whatever. We're making sure that we have private data, private identity, and private compute. I think it might make sense to just go through what that means, the data, identity, and compute, and why it was so important to have those three from day one.
Yeah, totally. I mean, private data is basically the core of Aztec, as in without it, it's not. It's just another blockchain.
Exactly.
But that's the unique difference. You can hide information in your smart contract,
like a private balance, or
and it just works. And that now then extends to identity, because privacy is a very hot narrative in Web3 these days. But I gave a talk just earlier at EthCC, and I asked the people attending, how many people actually actively use private blockchain technologies, and basically there was 3 people who raised their hand. It's just a narrative, because I would argue it up until now, the technology for consumer grade applications doesn't yet exist. And one of the reasons is, you have all these various random hodgepodge solutions all over the Web3 space about doing you can do private tokens under certain conditions, but they don't do private identity. And this is kind of important, because if suddenly everything about what you're doing is hidden, you probably need to prove something about who you are to the network that the smart contracts that are executing all of this, because it's otherwise you're creating a situation where good, honest actors are probably helping bad actors, malicious actors hide in the anonymity set. But more importantly, you just can't do important real world stuff. To give an example, let's take how Web3 accounts kind of suck. You're like, on an Ethereum account, so here's your private key, here's your seed phrase, blah blah blah. How about, but with Aztec, we have account abstraction by default, and you can combine that with our privacy features to say, you can make an account smart contract where what it does is it verifies your Google Auth sign-in flow. So I can say I'm Zac at gmail.com. I don't have Zac at gmail.com. I wish I did. But
in case everyone's going to email you now. It doesn't exist.
So if I had Zac at gmail.com, I could basically have a smart contract which verifies that the sign-in flow. And so I'm signing into my account with Google, and that's it. It's not a proxy for a private key. That is the authorization. And maybe that's not suitable for all use cases, because then Google kind of knows a little bit about, they know you're logging in. But it's for hot wallets, that basically is perfect for consumer grade stuff.
The signing flow is intentionally open-ended to the developer, so that if they want to implement biometrics or even the simple password, it doesn't have to be ECDSA key by default. It can be kind of anything
Google,
they want.
It can be an X account. It could be, if you want to be crazy, it could be a passport scanner. It could be you could have a proven existence of an email if you really wanted to go down that road. It really just explores the design space of what you can do in a smart contract. And we're gonna. My co-founder Joe might talk a bit about this, but with something he's building. But I think it's gonna define powerful new user experience patterns for blockchain.
Yeah, I mean, let's go into it a tiny bit now. I think it would be worth it. I'd love to hear what you think about what alpha means for the future of the industry and why programmable privacy is so important for the blockchain industry. Yeah. I think we should go into that a little bit.
Well, it's all about showing, not telling, isn't it? As in, I've been doing this for 8 years now, and for 8 years I've been talking about how privacy is the missing link, how this blockchain world of synthetic assets and synthetic NFTs can't expand. So I can't see anything with my glasses. Take them off. It can't expand into more tangible and real world activities because of the lack of privacy. But now you can actually build applications that do it, that walk the walk. That's what Joe is going to be doing at Aztec Labs. It's what the Foundation is assisting a load of our ecosystem partners with. It's it's not just going to be us in podcast studios and in conference centers talking about, this is the things you can do. It's going to be you can do it. I'm myself building some applications on Aztec to kind of to demonstrate the network, to provide some technology examples. And it's very refreshing. If I can give a small anecdote here.
Please do. So I love an anecdote.
When I started in blockchain in 2017, I started writing smart contracts because I was getting into this with my co-founders at the time, building private credit markets, boring, valuable stuff. Basically, all the most valuable stuff is pretty boring, and so. Apart from Aztec, but basically TradFi on blockchain, and I was writing a bunch of smart contracts to make this happen. Then obviously at some point I realized, oh wait, I need privacy, I can't like put multi-billion-dollar portfolios on a transparent network. That's not going to fly. And so that ended up on us going on a minor detour over the last 8 years of, I became a cryptographer. We researched and developed novel cryptographic primitives, published papers, turned the papers from math into code, and then built products around them, and then built an entire network and a programming language, etc., etc. Now, 8 years on, I'm back to writing smart contracts, finally.
Yay!
But this time they're Aztec smart contracts, and they have the private data that we always needed. And so we're going to, over the next few months, we're going to be showing, we're not going to be telling, with working examples and end-to-end demonstrations and applications and things that people can use and touch that show like functionalities that just don't exist right now on blockchain.
Mm-hmm. Yeah, let's stay there for a second, going back in time with a little story time.
Yeah.
I do want to talk as a kind of, I pride myself on being a bit of a nerd. As someone who, because you have a physics background, I know, and I also have a background in physics, less impressive than yours. I would love to hear.
We're both physics refugees.
we are indeed. And so I actually found out about Aztec through a podcast you did with Dagachi. So this is kind of like a nice full circle moment for my career. Nice. So I would actually love to hear a bit about how you came from your physics background to working on Aztec and making cryptographic breakthroughs and all of the things that you did. I'd love to hear about those breakthroughs and just how you got there.
Right. Well, so as an ex-physicist, you probably understand that, when you do a physics degree, you kind of have this kind of life crisis at the end of it, because you realize that you spent 3 to 4 years of your life basically like becoming good at something which is very weird and niche, as in
yes,
unless you want to do hardcore physics research, if you want to get a job in the real world, you can do engineering, but not as good as a proper engineer. You can do computer programming, but not as good as a proper computer scientist. You can do maths, but not as good as a proper mathematician. So you basically you have a lot of skills, but you're not an expert at any of them, and you've got to find a way forward. You've got to find a path in life. And so this led to me meandering around a bunch of random occupations until I fell into blockchain, because just through pure serendipity, my brother's best friend was like the guy called Tom Pocock, who wanted to do some TradFi thing. He was a trader. He was a guy, like an accountant, and he needed a technical co-founder. And I'm like, well, I'm not doing anything interesting right now. I had some boring programming jobs, so I'm like, yeah, let's do this blockchain thing. Why not? But then through the course of that, we discovered, we need privacy for this application we're building. And because I was addicted to the idea of doing a startup, like actually having some control over my fate finally, I became obsessed with this. I'm like, I have to solve this problem. And because of my physics background, I had enough of a mathematical understanding to sort of understand cryptographic papers.
Mm-hmm.
Back in the day, it was not like it is today. There's loads of easy learning resources if you want to learn about zero-knowledge cryptography. No. In 2017, you had there was like a cryptography Stack Overflow. We had cryptographers talking to each other.
Wow.
And you had academic papers, and that was basically it. And so I spent many months basically just like poring over these papers, which I didn't really understand, but it would basically be like a treasure hunt. I would read a bit of the paper, and if I didn't understand what it was talking about, I'd look at the thing it was referencing, and then I read that paper. And if I didn't understand what that was talking about, I would read its references. And eventually, you go back far enough that you have that it starts getting more basic, and you can understand it and reverse engineer it. And good lord, it was a very hard way of extracting a limited amount of knowledge, but it allowed me to become a cryptographer and do some cool research. Met some incredible influences, people like Jens Groth, people like Ariel Gabazon, like titans in their field, who really helped to like mentor me and educate me, and allowed us to make some pretty impressive breakthroughs in the field.
Mm-hmm. And I would say that you're pretty influential in the space yourself. I mean, that's how I got into ZK. So I feel like you've had your people that influenced you, and then you've also influenced another realm of people who will get into the ZK space. You should definitely go into a bit about those cryptographic breakthroughs, what they were, and
all right, so
why they were so important.
Well, I can talk about them, for sure. So the original one was called Plonk, Permutations over the Lagrange base for ecumenical non-active arguments of knowledge. So back in 2019, right, you have ZK snarks and you have ZK stars, but the ZK stars really expensive to verify on a blockchain like Ethereum, and the ZK snarks will require trusted setups. And if you want, which we wanted at the time, like programmable business logic was how we viewed it. You know, like you want to like define some basic logical rules around a financial transaction and keep them private. You don't want all of your clients having to run their own trusted setups. Like these at the time we were trying to serve financial institutions, people who like fat finger computers and like don't understand tech. We can't have them running trusted setups for every single app they want to use.
And for those who, sorry, just to interject, for those who don't know what a trusted setup is, can you just
sorry about
define
that.
that?
Trusted setup is basically the idea is you've got to generate some secret numbers, and produce an encrypted version of those secret numbers. And if the secret numbers ever leak, you're doomed basically. Like people can fake your proofs, they can break your proofs. So it's hard to do securely. You can do it securely, but not, you don't want to do it very frequently, because it's a huge overhead and like a mental overhead, security overhead to pull this off. And so in 2019, I was obsessed with this idea of saying, okay, can we make a fast Zk snark that either doesn't require a trusted setup or has something we call the universal trusted setup. The idea is you run this ceremony once to generate this encrypted secret information.
That will work for every
single program.
every program.
So you only run it once and you forget about it. And at the time, so I remember I was devouring papers by Jens Grotz, a titan in this field, and he was basically this talking about this idea. This idea which was crystallizing of separating out. It's called like your like circuit arithmetization and your polynomial commitment scheme. Basically, the idea is you have to transform your computer program, the thing you want to prove. You have to transform that into an algebraic form that you can easily create cryptographic proofs over, and then you need to prove that algebra. And these two steps were very unified back in the day, and you had these very monolithic proving systems with their own strengths and weaknesses. And what was starting to form was this idea of creating a more like modular way of building these proving systems. Then there was this other paper called Sonic, which was basically the first. It was a universal snark, the thing I was searching for, but it was really slow, like painfully slow, impossibly slow. And so I'm thinking, okay, can I combine these ideas from Jens with these Sonic ideas and maybe make something that works? I had this looking back, one of the best times of my life, basically, like hanging out in a bougie cafe in Shoreditch, next to where I lived, next to where I lived, like just with a notepad with these papers, and just spending days after days in that coffee shop, just like obsessively scribbling and trying to understand and trying to decipher, extract information from these like papers and see if I could rework it. But that wasn't. I wasn't making much progress by myself. But then I went to a cryptographic conference. I think it was actually just a blockchain conference, and I ran into Ariel, who at the time was at Zcash, and I vaguely knew. I knew of him by reputation, but we had met once before, but not really. And somehow I cornered him. I started rambling about these problems I was experiencing and struggling with. And this is like, to his immense credit, he actually listened to me, because normally at the time, because I'm not a formally trained cryptographer, so the language that I was, particularly at the time, the language of cryptography that I spoke was pretty broken.
Yeah.
You know, it's a bit like, somebody kind of turning up in English and going like, like, hello, me, Zach, how you? Sorry, I didn't speak it very well. And most academic cryptographers would look at me and they smile and they nod and they'd go on that way. But Ariel listened to me, and I posed a problem to him. Basically, this concept of, it's very common now, called cyclic shifts. Basically, I have this vector of information I've encrypted and encoded in this zero knowledge form, and I just need to do like a left or right shift on this vector. That's what, but derive that shifted value from the encrypted form. And this was the missing thing I needed to get this snark working, and I couldn't figure it out. And I thought it was impossible. And then Ariel was like, "Oh, I'll think about it." And then the next day, I remember very clearly, I was walking into this conference, which was this office, bunch of open plan office space. And I was walking past the sofa that Ariel was sitting in, and he just leaned back and looked behind, and he was like, "Oh yeah, by the way, I solved that problem that you were working on." And I'm like, and it's like this shocking moment where I'm like, do you have any idea what this means? So I grabbed him. We got into a side room, and we basically spent the whole day hashing out what eventually, after many months, became Plonk.
Wow.
Which is something we collaborated on over many months to put together. And yeah, that was.
And now we've got Honk, and we've got Chonk, and all
Honk,
these funny names.
Turbo Plonk, Ultra Plonk, Mega Plonk, Honk Chonk. Yeah, lots of stupid names.
I mean, that kind of explains, I see on Twitter fairly regularly, and I'm sure it winds you up no end. Why did it take so long? And I feel like this really answers that question. Is like, you had to go right back to basics in the sense of like the principles. You had to go and build the new proving system yourself and come up with the new cryptographic primitives. Then you had to build the actual prover. You had to figure out all these different things, like how do we get Zcash but with smart contracts, like Ethereum for Bitcoin. And then now we're finally at the point where we have where there is a mainnet.
Yeah.
And I would love to hear, just to kind of like wrap things up, what you're most excited to see people build. And then also maybe you can talk a little bit about what you're building for fun, like I know you were building some kind of chess example. It reminded me a bit of it's a card game.
Yeah.
I was going to say it reminded me a bit of the sort of 4D chess, you know, in Star Trek.
Oh,
but
yeah.
It was like an iteration on that, but more a card game. Anyway, so just to get people excited about what they can build and what you're kind of experimenting with.
So there's what I'm really excited by is unlocking a lot of the original grand visions for Ethereum. You know, like things that connect to the real world. I'm excited for things like using existing Web 2 flows to log into your crypto accounts. I'm excited to create, for people to create private stablecoins. Ideally, I'm always a big fan of them, of MakerDAO. Ideally, maybe experiment with collateralized stablecoins, but private. Private prediction markets, private OTC desks, private governance as well. I think that this is more of a passion project of mine, a passion hobby. I think that blockchain as a social technology, as a way of organizing communities and groups of people, has basically failed to materialize, but it was one of the original visions of blockchain back in 2016, right? Ethereum launched the DAO project, where the idea was it's going to be this community-led organization that invests in various projects in the ecosystem. And there were these very lofty ambitions to basically create a form of social organization that was somewhere in the middle between a corporation and a charity. Basically a collective group of people who have a common purpose and a shared goal. They might be driven by profit, they might be driven by ideals, probably both. And it gives them a technology where they can coordinate and execute without having to have these centralized middlemen, without having to have strong controlling actors. And this all obviously failed. We don't have powerful, impressive, decentralized, autonomous organizations today. But I think a huge part of that is the lack of privacy technology. The fact that you can't do your governance votes privately. These DAOs don't have an understanding of who its contributors are, because you can't put real world information into these smart contracts. They can't even do things like payroll or treasury management privately, which I think is another thing I'm excited for: private treasury management, private payroll, private agentic payments, X402 at scale. Things you can do all of this with Aztec.
That's so exciting.
The universe of things.
Well, that was a fantastic thing to end this on. I think people can hopefully start building things now that Alpha is live.
Yeah.
And I also just wanted to say a massive congratulations that you came all this way, and then now Alpha is live. And thank you very much for joining me in this podcast.
But it really is. It's a team effort. It's not just me and Joe anymore. There's over 80 of us now. So
yeah, there are some absolutely awesome people working on Aztec. I've had a pleasure of meeting a vast majority of them, and they're all very clever and also wonderful people. So you have the best minds behind it.
I'm very biased, but I think I agree.
Yeah.
I definitely
100%.
agree.
Well, thank you so much, Zac.
Thank you very much, Ciara.
And